Hello everyone. In this video we're going to take a look at some aspects from the third quarter project, specifically parts 2 and 3, which deal with systems of equations, which is a topic that we're kind of building towards right now in class with the equations we've learned how to solve. So I've made a mock scenario here. It's limited to what's included in your project. It's also different than the numbers in your project as to not give you any answers, but it's kind of modeling some of the basic skills that you're going to be doing. So in this case, I created, like I said, this little play scenario here. We have 230 people that went to or attended a game on Friday. The ticket prices were as follows. It was $7 for an adult ticket and $3.50 for a student ticket. Altogether, they made $1,435 in ticket sales. Okay, so we ultimately want to answer here is how many people or how many adults attended and how many students attended. Because as of right now, we'd be more or less just guessing some number that would add up to 230. But to algebraically determine this, we can use what's called a system of equations. So the first thing is to actually begin writing these equations. A system is just a set of two or more equations, so we obviously need to start by writing one. I'm going to start with the variables here. In your project, your variables are defined as A and S. So I'm going to say let A equal the number of adults, and let S equal the number of students that attended on this Friday. Okay, so now the simpler equation here, I refer to this as your number equation or your attendance equation, I believe it's called in the project. If 230 people went in total, and we only have adult and a student ticket values to consider, there's no senior citizen, there's no other random type of person or ticket that we're dealing with. We only have these two possibilities. Therefore, if I add up the number of adults that are going, if I add up the number of students that are going, it should add up to 230. Okay, so that's a rather simple equation. Now we want to involve a money equation, something with coefficients involved. And that's going to refer to that second bullet point. If each adult that goes is paying $7, and each student that goes is paying $3.50, I'm just going to write it as 3.5 S, then altogether that should add up to our money amount of $14.35. Again, where are these coefficients coming from? Or why can't we just use A plus S equals $14.35? We want to represent that for however many adults that go. For example, if 2 adults went, that would be $14. So what am I doing there? I'm multiplying however many adults go by 7, or 7a. And it's the same thing with students. However many students go is going to be a multiple of 3.5. Adding them together would give us our gross revenue here, or ticket revenue of $14.35. So that's why the coefficients are included in one, the money equation, and not included in the other, which is just a simple number or more or less counting equation. Okay, now the tricky part here, and the project prompts you to do this a little bit more directly. How do we solve this? Okay, we have two variables. If we solve each of them independently, they have an infinite number of solutions. The top one would just be a line, and the same thing with the bottom one. A line meaning that there's, like I mentioned, an infinite number of possibilities. In the top equation, let's take a quick look. It could be 180 and 50. It could be 230. We can sit here and list limitless possibilities. So the trick is kind of working these two equations into one another. There's a few techniques with systems. There's an elimination method. I want to focus on what's referred to as the substitution method, which is also featured in some of the prompts in your project. So for the substitution method, we're going to solve one of these equations for one variable. We're going to do the same thing that the project asks you to do. In this number equation, I want to rewrite it, not change the value of it or its validity, but just simply rewrite it to say S equals. So what would I have to do to get it to say S equals? I would simply have to minus A from both sides. I could put negative A plus 230 or 230 minus A. Again, that's an equivalent equation. All I did was subtract a from both sides, utilizing the subtraction property of equality. So now, if I have a statement that says s equals blah, 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 some value, in this case 230 minus a, in that bottom equation, wherever I see an s, I can now replace it. This is why it's called the substitution property. In other words, if I know the value of s in terms of other variables and numbers, I can replace that s with those values and numbers. And what's the point of this? We'll see in a second. Once I start replacing the s with those values, I'm going to go from an equation with two variables to an equation with simply one. So I'm going to rewrite that bottom equation, but now instead of s, I'm going to put what it's equivalent to, which is 230 minus a. Again, we're thinking of these equations as a set combined together. In other words, there's not different a and s values in each equation. They should be the same thing. That's why I'm allowed to plug in or substitute into a different equation. Okay, so now this should look a little familiar as a multi-step equation. And again, we only have one variable. And a one variable equation can be solved. So I'm going to do some multiplication here. I'm going to distribute. I'm going to get 7a plus 3.5 times 230 would be 805 minus 3.5a equals 1435. I'm going to combine like terms, and I'll get 3.5a plus 805 equals 1435. Okay, subtracting 805 from each side will give me 630. And now I would simply divide each side by 3.5, and I would get 180. So let's interpret that value really quick. If a equals 180, that means that 180 adults attended. Okay, so now you could do the simple arithmetic of saying, all right, 230 people went. I know 180 adults went, which means 230 minus 180 is 50 students attended. Okay, you could also think of that in terms of rewriting the top equation, but now with your known value in. So 230 plus what? 180 plus what is 230? Simply 50. It would also work to plug into the bottom one, but the bottom equation, but obviously the top equation is a little bit easier to work with. Okay, so this is just to give you an idea of some of the principles, and again, the project kind of walks you through or prompts you to do each of these things, but this is a little bit of a quicker view of what you should be doing and why it works if you're a little confused about why you're doing a certain thing. What I also want to go over in this would be in part 3. So we're going to use the same scenario, but in part 3 of your project, it obviously includes different numbers than part 2, but we're going to pretend here the part 3 uses the same numbers. I want to go over the Desmos application. So I'm going to type in a plus s equals 230. And again, we would be using x and y here. Part 3 switches to x and y. So let's pretend this is x, this is y. And we're going to use Desmos. So I'm going to type in one equation, x plus y equals 230. If we zoom out, we're going to see a line somewhere there. There we go. And now the second equation is 7x plus 3.5y equals 1435. Again, just for time purposes, I'm using the same numbers as our mock part 2. Obviously, the real part 3 is a totally different scenario. It also says right from the beginning to use x and y. The reason being, Desmos is a graphing application where we've learned that we only define the variables x and y for ordered pairs, the x-axis and the y-axis. Desmos will not read if you type in a plus s equals 230. So we see two different lines graphed here. If you can play around with the colors on the side, and you can change what they look like. You can also generate a table of values if you'd like. Could play around with some different things here. This is the app on my iPad, so it's a little bit different than the real one on the website. But more importantly here, we're looking at how when we type these two equations in, what happens to their lines? So we mentioned earlier, separately, these two equations have infinite values. So think about it, just the red line. Every single point on that line satisfies that equation. Now obviously this is a real world scenario, so only really this first quadrant, we can't have negative people, would satisfy it. But you could see there's a lot of possibilities. Same thing with the blue line. Separately, all those little individual points, which we can't see, but all those points making up that line satisfy that blue or second equation. So the question is, where are both of these equations satisfied at the same time? Or which x and y values, or a and s values in our case, which we just solved, satisfy both of these equations? It would simply be where the lines intersect. Kind of makes sense. It's a point on each equation, or each line, I should say. Okay? And the cool thing about Desmos, like I said, you could play around with some zooming features. Also, if you go near the intersection and kind of touch it with your mouse or highlight it, it will make a coordinate for you, and then again, just double clicking it, it will actually reveal the intersection, which says 180, 50, which means x equals 180 and y equal to 50 would satisfy both of these equations. It's a point on both lines, the red and blue line. And that was the answer that we obtained earlier. So this is just, again, going over some of the Desmos applications, zooming in, how to reveal an intersection. Again, just kind of click on near the area, you'll see a little point, click it again, and it'll actually reveal the coordinates. This one's a little bit larger than the value you'll get in part 3 of your project. So I'm a little zoomed out here. You can see this is going by like 50s, but obviously a normal graph, you could probably zoom in a little bit closer to see more realistic numbers. Okay, hopefully this helped with any questions you're having about the difficult aspects of the project, which are parts 2 and 3, the systems and the Desmos application. If you have any further questions about the project, please reach out to me by email. You can try to comment underneath this video, and I'll try my best to get back and help you out. Thank you guys for watching, and have a nice day.